Hello, thank you for the opportunity to have a conversation with you on Cloud Native Open RAN. Today we're going to discuss Cloud Native Open RAN as part of this Open RAN conference in India. My name is Azhar Sayeed. I am the Chief Architect as part of the telco team here at Red Hat. Before we get into the topic of Cloud Native Open RAN, first of all, let's define what Cloud Native Open RAN is. Very quickly, Cloud Native Open RAN means Open RAN components, which is a set of disaggregated RAN components, RU, DU, CU, and so on, run on a cloud native platform. It just doesn't mean that they are virtualized or containerized, but it means that they're running as cloud native workloads on that particular cloud native platform. Now, the idea of running them as cloud native workloads essentially means they're adhering to the principles of being cloud native, which means they're intelligent and they're actually run as microservices and they're elastic and manageable. So with that definition in mind, let's first ask ourselves the first question: why Cloud Native Open RAN? New requirements for 5G mean that you need dynamic orchestration, adaptation to demand, scale on the fly, manage spectral efficiency, and tunability of RAN components to meet throughput, latency requirements for these new services that 5G is purported to deliver, which is ultra reliable low latency, enhanced mobile broadband, massive IoT, and so on. Now, if you look at cloud is associated with elasticity, with flexibility, with efficiency, and scale. So disaggregated RAN components can then be deployed on commercial off-the-shelf hardware and be software driven and defined. So that means you can actually take a cloud platform or build a cloud native platform for RAN that allows you to use the benefits of cloud with respect to elasticity, scalability, efficiency, and so on, and put RAN components on top of that to make the RAN more adaptable, flexible, efficient, and dynamically orchestrated, which was the original requirement as part of 5G. So that's why we need cloud native for Open RAN. So then the next question becomes, what characteristics should this cloud native platform have for a successful Open RAN implementation? The platform must be capable of hosting, first of all, these RAN workloads and be able to scale according to these workloads and site requirements. Now, when you start to go deploy RAN, you're not deploying them just in one central data center, but you're deploying them near the cell sites, in your regional data centers, in your far edge locations, which means the requirements that they pose is very different. You need things like single node, multi-node, single cluster, multi-cluster, right? Distributed clusters, stretch clusters. So you need this compute capability and networking capability to be deployed in a variety of ways to address these RAN requirements. Also, this infrastructure must be capable of really addressing low latency requirements that RAN has. For example, if you want to run RAN DU, you need real-time kernel capability. You need hardware acceleration capability for forward error correction processing as part of RAN DU. You need to handle timing and synchronization. That's a requirement for RAN because you're deriving timing from your clock sources and you're redistributing that particular timing across to other nodes in terms of the different timing profiles that there are. So timing synchronization to support things like slave clock, boundary clock is important as part of the infrastructure. And then this platform that's running on this infrastructure, which is general purpose compute commercial off-the-shelf hardware, should be an open platform. Why? Because if you're deploying software components from different vendors, you should be able to mix and match these software components from different vendors to build an overall solution. So an open platform is important. Now, once you start to deploy platform in these locations, edge and far edge locations, you'd potentially be deploying other workloads there as well, such as edge compute, such as UPF for 5G core. Now, you could have a common platform that hosts some of these RAN workloads as well as the UPF and some of the other edge compute workloads as part of the infrastructure. So a cloud native platform is important and running RAN workloads in a cloud-native way across a particular cloud-native platform becomes incredibly important, as you would want to really deploy on the principles of cloud, manage that efficiency, and all of the things we spoke about a moment ago. And of course, the platform needs to be able to manage a complete life cycle of the infrastructure and the workloads, and automate this capability completely from end to end, so that these deployments are done in a zero touch way, in zero touch operations way. So then the question becomes, okay, so all this is good, seems like it's possible, but what are the obstacles? What about costs? What about standards and interoperability? What's the maturity of this? Open Alliance has done a great job of defining some of these interfaces, the front hall, the mid hall interface, and some of the other interfaces like the O2 for orchestration, E2 for RIC and RAN components, etc. Now these, and then there was interoperability testing being done in the industry via TIP, plug fests or plug tests, to actually showcase that different RAN components can work together. Then of course, because cloud native platform is being defined as part of the orchestration working group at WG6, you can then use now cloud native APIs to actually interface to the underlying infrastructure for observability, for telemetry, for tracking. So telcos are getting more and more involved, and there is now choice available to them from these different vendors, and it is maturing fast, as well as there is now interoperability. Now the question then becomes, okay, so what about costs? Well, numerous studies have been done in terms of costs. Maybe 3 years ago, it wasn't as cost effective because performance probably wasn't there and the workloads weren't really efficient at that point in time. Today, the answer is very different. Several studies have been done, and also some production deployments showcase some proof points that you can gain up to 37 to 40% CapEx and OpEx reduction if you go deploy cloud native Open RAN based on open components that are defined. Now, dynamic orchestration was one of the basic requirements we started with as part of 5G and RAN for tunability to address these different types of use cases and requirements. That is achieved now through addition of things like XApps and RApps with the RAN intelligent controller on that cloud native platform. So these XApps and RApps that you hear about, these are really microservices, and those microservices run on a cloud native platform. So what I'm really trying to say is the obstacles, the barriers are being lowered. There's now an ecosystem of vendors coming together to test interoperability and to showcase that you can mix and match radio components with RAN components and actually deploy on an open platform a full cloud native Open RAN. We know that RAN is all about scale. If you start deploying RAN and servers on all these different sites, how do you manage all these servers? Previously it was devices, we knew how to manage them on a traditional infrastructure. Now you're talking about deploying all these servers in general purpose hardware. Can you manage them? The answer is absolutely yes. Yes, it is indeed about scale. Yes, it is scaling from tens of thousands to hundreds of thousands probably in terms of locations. And we are already seeing some of these designs being put together. How they are managed and how they scale is primarily because automation is playing a huge role in this. Automation of components, of lifecycle management, of provisioning with zero-touch provisioning, zero-touch operations is almost a must in terms of deploying them at large scale. Observability and telemetry with data aggregation and correlation becomes then necessary for you to automate and create a closed loop cycle of managing these devices. So we've worked with our partners to create architectures that allow regionalized, centralized reporting mechanisms for manageability of these large deployment models. It's being done now in tens of thousands of sites. Not too long from now, they'll probably scale easily to hundreds of thousands of devices in this RAN. And these networks are live. Some of these networks are already live. So yes, it is possible, and yes, it is being done. But then, a common question that comes is, but wait, what is my requirements are very different. Especially in India, I have other challenges. How realistic is it for me? Well, this question is true for almost anybody across any geography in the world. Everywhere there are some unique requirements and there are some common requirements. It's about how you frame the argument. It's about how you actually design your system to overcome the obstacles that are there for you. For example, you don't need to boil down the ocean. You don't need to actually try to implement cloud native Open RAN in your entire infrastructure on day one. You can start small. You can, rather than take a one-shot approach, consider taking an incremental approach. Understand the value and experience the benefit, right? For example, starting small for Open RAN may be a very good idea. You can start in urban. You can use small cell as an excuse. Build these small edge clouds, right? Host these RAN CUs. You don't have to do both RAN CU and RAN DU at the same time. You can just start to host RAN CUs on a cloud native infrastructure and still do RAN DUs as an appliance. And then when you feel more comfortable, go down to the RAN DU and extend that particular cloud platform over there. Lack of fiber and high-speed capability really is an issue. I understand that. And you do require some of this for Open RAN type of deployments. But you know what? Split RAN actually reduces your fiber requirements on the mid-haul. So if you start to deploy DUs closer to the cell sites, then your fiber requirements or your high bandwidth requirements are only limited to that particular front haul. And even there, new innovation allows you to use Ethernet for that particular front haul, Ethernet-based front haul. So things are changing rapidly. You can deploy using Open RAN components and reduce some of those fiber requirements as well, thereby actually providing better efficiency. You just don't need to implement it for LTE. You can do it for 5G new radio, or in fact, majority of that Open RAN deployment, what I'm seeing today, is actually being done for LTE. Now, as you start to introduce 5G new radio, you can actually introduce these components there. So then the question is, when do I do it? And where do I do it? Well, as I said before, start small, learn, and then grow. You can implement Open RAN using disaggregated components with LTE. You don't need to wait. If you don't have the spectrum for 5G, you don't have the components for 5G, do it with LTE. Do it for small cell. You can mix and match these components with appliances and cloud platforms. And over a period of time, migrate that into a horizontal cloud platform. Using open source as a way to define that particular horizontal cloud platform, where you can actually onboard workloads from different vendors and deploy that, allows you to scale for the future. Architect it, find the right set of partners, create those logical insertion points, find the right set of partners, work with them that have the same mindset in order to be able to innovate in this particular space. Really, all I can say is good luck. You should not, hesitate from deploying a cloud native platform for Open RAN, regardless of where you are, because there is benefits to be had. You can start small, learn, and then grow. Thank you very much. Appreciate your time.